All right, so we want the derivative of this function. If this f of x is sine inverse of x, we want f prime of x. That's the same as using this notation. If we let y equal sine inverse of x, this notation is a little more convenient for the work we're going to be doing. If we let y equal sine inverse of x, then we want dy dx. dy dx is the derivative of y with respect to x. It's just a different notation than this f prime notation. Of course, what's going to happen is this makes it a little bit more straightforward to find this procedure, because what we can use is another one of the tools in our little toolbox. We remember the implicit differentiation. This is going to be a function. In this case, this is a function, but we're going to change this into an equation relating x and y, and we take the derivative in that equation form. That's the implicit differentiation procedure we're going to be talking about. So, we're going to write this as y is equal to sine inverse of x. Now, what I'm going to do is show you where this comes from. I do not expect you to be able to reproduce this, but I want to show you where it comes from, and I'm convinced that if you're shown where it comes from, you're much more likely to remember it. And once we see where sine inverse comes from, it's not very challenging to see what happens with tangent inverse and with secant inverse. And then we're going to talk about, well, why hasn't he put cosine and cotangent and cosecant? We'll see what happens with those as well. So the next piece is to show you where this comes from. Remember that this is equivalent in the scenarios we're talking about with appropriate restrictions, that sine of y is equal to sine of sine inverse of x, but sine of sine inverse of x is x, if these are appropriately defined inverse functions. And now we take the derivative of this expression implicitly. Remember that you take the derivative of any term involving only x, sort of as usual, but we assume y is a function of x, and we apply the chain rule. Anytime you take the derivative of y, you multiply by dy dx. As soon as you get the result, then you solve for dy dx, and that's the derivative you're seeking. So, the derivative of the left-hand side, the derivative of sine of quantity, is cosine of the quantity. And the anytime you take the derivative of y, you need to multiply by dy dx. That's the whole point. The derivative of the right-hand side is simply 1. Now, a thing to bear in mind with this equation, right? That corresponds to a triangle. Now, you may draw the triangle in any orientation you like, but I'm going to draw this always the same picture, always from the same perspective, always with the same labeling. We have sine of y is equal to x. Now, we know this is, we know SOHCAHTOA, we know sine of something is opposite over hypotenuse. So what does this correspond to? Well, first thing, I'm going to make this into a fraction. So this is the opposite. This is the hypotenuse. Now, the hypotenuse is straightforward. In any such triangle where we're talking about sine, the hypotenuse is always the side opposite the right angle. So, since I have x over 1, I know the hypotenuse is 1. But now the question is, which side is opposite, which side is adjacent? From the perspective of which angle are we approaching this problem? You may approach it from any perspective you like. However, it's easier if you always do the same procedure. So without loss of generality, I'm going to assume, now in this expression, sine of y, remember y must have been a value in the domain of the sine function. And we have our little set picture up here. So y is the domain value. This is an angle. Y is the angle. Y is that angle. It is the radian measure of this angle. I'm always going to choose the lower left angle for my triangle. You are free to choose the other acute angle if you like, But if you always do it the same way, it always shuffles out and it's much easier to remember things. So I'm always going to label this as value y. So from this perspective, yes, this is the hypotenuse, but now this is the side opposite. This is the angle, this is the side, so the side opposite must be x. And now what's left for us to do is to compute the length of this third side. Let's call it t and solve for t. Well, I know t squared plus x squared is equal to 1 squared. And so that means t squared is equal to 1 minus x squared. I'm going to find what the value of t is. And so this implies that the square root of t squared, or simply t, is equal to the positive or negative of the square root of 1 minus x squared. But this is a distance. We want t to be positive. We are choosing t to be the positive distance. And so we choose t to be the square root of 1 minus x squared because we want this to be a distance. And so this third side is 1 minus x squared. This comes from Pythagoras. This comes from SOHCAHTOA. This comes from SOHCAHTOA. Those are given. That comes from Pythagoras. And so given any such expression involving sine, later on, tangent, and secant, given any such expression, we can determine the values of this triangle. 2 of the sides will be given because we turn this value into a fraction. 2 of the sides will be known. The third side can always be found from Pythagoras. So, I'm going to erase some of this clutter. This is the triangle we're going to be dealing from. All right, so we have sine of y is equal to x, cosine of y, dy dx is equal to 1. Our task now is we're almost home. We want to find dy dx, right? So this means dy dx is equal to 1 over cosine of y. Now some students want to put this as secant, but it's the same result. It's just easier not to go that route. The problem or the issue we have is this. This is a function of x. We want f prime as a function of x. This is not a function of x, it's a function of y. And so we need to translate cosine of y into an expression involving x. And so, how do we do that? Well, we take cosine of y and we look in this triangle and find it. We know that y is the angle in question. We know cosine is adjacent over hypotenuse. Right? So the cosine of this angle, the denominator of this expression is the cosine of this angle, which is hypotenuse. I'm sorry, it is adjacent divided by the hypotenuse. And so what we generate is this. dy dx, which is f prime of x that we're looking for. Right? It is the f prime we're looking for. Is given by 1 over, and I'll go ahead and work the details out. Cosine is adjacent over hypotenuse, so that's the square root of 1 minus x squared over 1, but over 1 we may ignore that piece. So this is our result. F prime of x is given by 1 over the square root of 1 minus x squared. The derivative of sine inverse of x is 1 over the square root of 1 minus x squared. That's correct, that's accurate, but that's not the way it's typically stated, and that's not the way you should learn it. What you should learn is this. We don't want that. We want to learn the basic form where u is some function of x. We want to learn the chain rule form, and that's what this expression is. If you look in your list of basic forms from earlier in the semester, this is the one that's listed. So this is the form that you learn this. This is the form you need to memorize this. You need to memorize these. All right? And so it is 1 over the square root of 1 minus u squared times u prime. Some people learn this where they put the u prime in the numerator. If you put u prime over this radical, that's fine. But this is the form that I think I have on the sheet, and this is the form you should learn. So d by dx of sine inverse of u is given by 1 over the square root of 1 minus u squared times u prime. All right? Now, without going into the detail, I will simply state that in a similar way, you go through a similar construction, a similar process, and you get this is 1 over 1 plus u squared times u prime. And secant inverse is 1 over absolute u square root u squared minus 1. Oops, I need u prime. You can find those in the formula sheet or the basic form sheet, or you can find that right here. But these are the three values that you need to learn. These are the three values. There is nothing for it. There is nothing for it. You need to learn these. The derivative of sine inverse, 1 over square root 1 minus u squared times u prime. Derivative of tangent inverse is 1 over 1 plus u squared times u prime. Notice, tangent inverse does not have the radical. It's related to the fact, it's not the same thing, but it's related to the fact that the derivative of tangent is secant squared. And if we were to go through that procedure, the fact that the derivative of tangent is secant squared, whereas the derivative of sine is only cosine to the first. When it's to the first power, this radical is retained. When it's squared, this radical turns out is squared away. And so tangent inverse does not have the radical. And then secant inverse, notice there are multipliers in the denominator. That comes from the fact that secant, the derivative of secant, is a product, secant times tangent. And if you work all the wash out, that's what it generates. Also notice that secant inverse, the derivative, this must be absolute value of u. That's a very important piece of the puzzle. The details of that we're not going to go into, but for your purposes, those are the three values you must memorize. And now the last little piece is this. Why am I not discussing cosine inverse? And here's why. The derivative of cosine inverse is precisely the same as the derivative of sine inverse, except it's negative. The derivative of cotangent inverse is precisely the same as the derivative of tangent inverse, except it's negative. And cosecant and secant have the same relationship. So if you know the values for sine, tangent, and secant, you get the values for cosine, cotangent, and cosecant for free. And even more good news, these are extremely useful. They're very valuable for the work we're going to be doing, you'll be doing in Calc II. When you get there, it turns out that you almost never use cosine inverse, cotangent inverse, or cosecant inverse. And so those values are typically not required of students to memorize, although all you need to do is put a negative sign in front of it. Anything that can be done with cosine inverse can be done with sine inverse, and you avoid the negative sign. So, that's the very, very long of it. The very, very short of it is this. Your assignment, learn those. And in the next video, we'll talk about how to work with derivatives involving these, because yes, each of these knows how to play with product rule, quotient rule, and chain rule.